Okay, in this video we're going to introduce exponential functions. So imagine this scenario. So imagine you're almost broke. For some of you, maybe that's not so hard to imagine. But so let's say you only have $3. But luckily you have a rich uncle and he's offered you either to give you $1,000,000, which is pretty awesome, or he will double your money every day for a month. So you only start with $3, but he's going to double your money. So day 0, that's today, you've got $3. But tomorrow he's going to double your money, so you'll have $6. The day after that, you'll have $12. So let's see which offer would be the better way to go. Should we just take the $1,000,000 or should we have him double our money? So if we're going to solve this problem, probably your most intuitive thought is let's start with like a table of values, right? So we have $3 and $6, then $12, and we start doubling our money. We get $24 the next day, $48, then $96, then $192, and we keep going, $384. And at this point, you're probably wondering, like, man, there's probably got to be a more efficient way to do this, right? Because we're already on only day 9. So at this point, it's sort of seeming like, well, we're almost a third of the way through the month, and we're only at $1,500. It seems like $1,000,000 might be the way to go, but there's got to be a more efficient way of doing this, right? So is there a more efficient way to answer this question? And of course, the answer is yes. So let's think about that. How do we do that? What we'd like to do is come up with an equation. So if we want an equation, what we want to do is notice the pattern. So as it's saying here, so there is a pattern. And what is that pattern? And I'm not saying you should look down this second column and say, oh yeah, the numbers are doubling. Well, of course the numbers are doubling. That's how we found them. That's not what we're looking for. We're looking for a relationship between, I want to come up with an equation for what can I do to these numbers in the left column to get to the numbers in the right column. So for example, what can I do to the number 7 and get an output of 384? And that same thing I need to do to the number 8 and get to an output of 768, right? So that's not doubling. I'm not multiplying that by 2. So what is the pattern? So to notice the pattern a little bit more closely, let's go back to the beginning and think about how we really created these values. So we did start with $3, and then we were multiplying by 2. So this 6 is 3 times 2. And then we took that answer, so we took that 3 times 2, but we multiplied it by another 2, right? That's how we got 12. Then we took that number, which we could write as 3 times 2 times 2, and we multiplied by yet another 2. And so every time we go up by one day, we add another factor of 2. So sure enough, 48 is 3 times 2 times 2 times 2 times 2, but we wouldn't really write it that way. We'd probably write it as 3 times 2 to the 4th. And this one, 24, we'd write as 3 times 2 cubed. And here we'd write 3 times 2 squared, and etc. This one would be 3 times 2 to the 5th. So now can you see a pattern? So in fact, I'm going to highlight this exponent here. Okay, now we'll go back to our pen, right? So can you notice what could I do to this 7 to get 384? Well, hopefully you see the pattern. It's 3 times 2 to the 7th power, right? So the input 7 is my exponent, right? And remember from our last video that order of operations is going to be key here, because this is not the same thing as 6 to the 7th power, right? This is 3 times just the number 2 being multiplied by 7 times, right? 2 is being repeatedly multiplied, not the 3. Okay, so for part B of this question, they're asking us to write an equation. If we let x equal the number of days, can we write an equation? And the answer is yes. We could say y is going to be 3 times 2 to the x. Okay, and so this is going to give us our input and our output. We input x many days, and this output will tell me how many dollars I'll have. So if we use this equation for part C, let's find out how much money we would have after 30 days. So this is going to be much more efficient than actually completing the table for 30 days. All we have to do is let x equal 30 days. Now, order of operations, how do we compute this? We do 2 to the 30th power first, and then we multiply that by 3. So it's going to be 3 times a really big number. So I've done this ahead of time, and I get 1,073,741,824, and then that times 3. So we really end up with 3,221,225,472. So that's over $3 billion. I think we should take our uncle's $3 billion over $1 million. So I'm wondering if this is surprising to you. And if you know anything about exponential functions, which is what this is, and we're going to talk more about this in this unit, then maybe this wouldn't be so surprising because exponential functions grow very, very, very rapidly. In fact, if you ever hear someone talking on the news about something growing in an exponential fashion, stock prices growing exponentially, things like that, you probably know that that means it's going very high. It's going very fast, right? All right, so this last question on this page, the question asks, how would the function, oops, that's a typo, change if you started with $50? So notice that in terms of the pattern here, the $3 was sort of, didn't matter, right? That was that first value 3, but then from that point on, we were doubling money. So it was the 2 was being multiplied repeatedly every time. So hopefully you see that what's going to happen is the function wouldn't change very drastically. It would just be $50 times that 2 to the x. So this value right here is our starting value when x is 0.